adding another column called supplier. It's an integer column that doesn't allow nulls. Explicitly, we're not allowing nulls in that column. And I'm also adding something called a constraint. And constraints are something you'll come across quite often in databases. They are rules that we apply to a particular column. So in this case, I'm saying the constraint is that this column has a default value of 1. So whenever I try to insert a value into this table, if I don't specify a value for the price column, which allows nulls, then we'll end up with a null there. If I don't supply a value for the supplier column, which doesn't allow nulls, but does have a default value, then we'll get the default value of 1. That make sense?
Sure. So if we don't know the value, something will be supplied for us.
Exactly, yeah. Now, we've looked at create table, we've looked at alter table. The final thing you might want to think about is, hey, I made a big mistake. I don't need that table at all. I can drop that table. And the way you drop a table is drop table. Don't get mixed up with drop and delete.
Right.
Delete is used to delete data in a table. Drop is used to delete a table, to drop a table from the database.
So we've got create and alter and drop.
Yeah.
Collectively, those are data definition language, right?
Exactly.
DDL.
DDL we'll quite often talk about, yeah. So a couple of points that we've made then, just to kind of reiterate then. You create tables using the create table statement. You specify the name and the column specifications for the columns that are in that table. You can modify a table definition using the alter table statement. You use that to add or remove columns, constraints, keys, that type of thing. And we can remove tables by using the drop table statement, and that just removes that table from the database. So
now, if there's data in a table and I drop the table, what happens to that data?
You lose the data.
So we've got to be really careful about dropping tables.
Exactly, yeah. You have to be very careful with that.
Is there an undo in SQL Server?
Not for dropping tables, no. I guess you'd have to restore from a backup, which is usually the answer to that particular problem. All right, so we talked a little bit about creating tables then. Let's turn our attention, once we've got these tables, we obviously need to get some data into them. So let's perhaps look at that.
All right, sure.
Okay. Well, we'll go back to our idea of working with data in tables, and we'll go back to our SQL language that we use for doing this. So here's my table. Now, earlier on, I put some sort of italicized values in there just to really show what type of data went in them. In reality, if we just created a table, it's empty. There's nothing in the table. So if I want to insert some data into that, you'll be amazed to learn that...
Is there an insert command?
There's an insert command. So we actually do insert into the table, and I can insert the values in that table. Here we're just simply specifying that we're inserting these values, and we're just using the location in the values clause there to correlate with the position of the column in the table. Notice I haven't specified anything for product ID. You remember that?
That was the identity column, so that's going to auto number.
Exactly. So when it's an identity column, that's the kind of exception to the rule. You don't have to specify a value for that. And what we've done is specify the values for the other column. So we've specified the name column, the price column, and the supplier column, and we've given those values. We've inserted a widget at $12.99 into there.
Do the order of those values matter?
It will, because that correlates to because we haven't specified which columns we're inserting into, it has to go with the order that the columns are in the table. And what we can do is specify explicitly which columns we're inserting, in which case we can do it in any order we like. We just say we're inserting into the name, price, and supplier column these values. Now, they happen to be in the same order, but they don't have to be in this case.
And if you left out any column names from the insert list, what happens?
Well, that's where it gets interesting. You might remember we had the idea of our price there that supported nulls and our supplier that had a default value. So in this case, I've just inserted into name. I haven't specified anything for product ID because that's an identity. I haven't specified anything for price, and I haven't specified anything for supplier. So we insert the name knickknack, but then in our price column, we get a null because that column allows nulls, and we haven't specified anything else to go in there. And in our supplier column, it doesn't allow nulls, but it does have a default value. So we get the default value of 1 appearing in there. So the rule is, if there's a default, you'll get the default. If not, and it supports nulls, you'll get a null. If it doesn't support nulls, you'll get an error at that point. So if I do something like insert into product, in this case, I'm explicitly saying null and default. I can do it that way as well if I know I want to insert null and default. But if I do something like insert into product, something like that where the data type's not right, so I've said I want this thing to be free, and I've inserted that as a string, then I get an error because it's the wrong data type.
We need a 0 there instead of the word free.
Exactly. And this time I've inserted a 0 there, but I've specified null for the supplier, and supplier doesn't support a null value. So I get an error in that instance as well.
And that seems to make sense because we need to know what the relationship is to the supplier table for that row. So we can't just leave it out.
Exactly.
We need to know who that supplier is.
Yeah. So we can use these constraints that we place upon the columns in the table to enforce some sort of integrity in the data. It just prevents us from doing stupid things like inserting products that don't have suppliers. All right, well, we've inserted some data into this table. I guess the next thing we want to do is get some data out of it. So let's take a look at that. And the way that we do that is with this idea of a select statement. So we've got select. In this case, I've said select star. What's that about?
That means I want all of the columns.
Right. So it's shorthand for saying just bring me back all of the columns in the database. And because I haven't filtered on the rows either, effectively what I'm doing is bringing back all of the data in that table.
And that's okay for a teaching example, but do I want to do that in my applications?
I suspect you don't. As your tables get larger and as you're accessing this thing over a network, you don't want to be bringing back data unnecessarily. So usually we would advise people don't use select star unless it's a very small table or you're just, you're testing things out. Typically you'll specify the specific columns that you want. You specify the specific columns. There you go. I have to talk about tautology. So we're getting the product ID, the name, and the price from the product table in this case. And in my result set underneath, that's exactly what I get. I get those columns.
And the order in which I list them in the select clause determines the order in which they come back, right?
Exactly, yeah. Now in this case, there's something interesting going on. I've brought back the name product, but I've specified bring back name as product. So I'm giving it a different name in the result set. Notice in the result set, the column is called product, even though the original column is called name. Mm-hmm. And similarly for the price, I'm not just bringing back the price, I'm bringing back the price times 0.9, multiply by 0.9. In other words, take 10% off, and that's going to be my sale price.
Well, so we'll have to check with the manager.
Yeah, we may have to check that I've got permission to do that. But notice that it's gone ahead and it's multiplied, where there is a price, it's multiplied it by 0.9 and give me that value. Where the price is null, well, anything multiplied by null is null. An unknown value divided by 10 is unknown, so we get null.
And interestingly, it's null. It's not an error.
No, it's not an error.
It's not like I'm doing an operation on 0.
Yeah, but the default behavior, and you can change this if you go into the settings, but the default behavior is that a null, if you do an operation on a null, any operation with a null results in null, which makes sense. The price I don't know multiplied by 10 is something I don't know. Now in this case, I'm applying a where clause, and that's a new thing we're introducing in the select statement at this point to show how we would filter the rows. We've seen how to specify the columns I want. In this case, I'm also filtering on the rows. So bring me back only the products where the supplier is supplier 2. And that's how we do that.
And one of the things that you'll need to get used to, and that's something we cover in more depth in our t-sql MVA and some of our other t-sql courses, is the order in which the database engine is interpreting that statement. And so learning that it looks at the from clause and then it applies the where filter before it then selects the columns starts to help you understand as these statements get more and more complex what the output's going to be. But we'll keep it small now.
Yeah, exactly. There's an underlying engine, the query engine that interprets the SQL you type. The SQL actually is fairly, I think it's quite intuitive. It's a syntax that's, you could read that and pretty much know what it does, even if you've never done any SQL before. But that's not necessarily what gets interpreted under the covers by the query engine. So some key points we've covered then. We insert data into a table using the insert statement. And when we do that, we can either specify explicit columns or we can support defaults or nulls and insert into those values. We can select data from a table using the select statement. And we do that by specifying the columns or expressions. We had some calculations in there that we can use, and that brings back what we want to get in our result set. We can use aliases or alternative names, if you like, for the columns in the result set. We use the as clause to do that. And we can filter rows using the where clause to bring back only the rows that satisfy that filter criteria.
Mm-hmm. So you've got some demos of this to show us, right?
I have indeed. Let's go and take a look at creating a table in SQL Server. So here we are in SQL Server Management Studio. I've got a SQL Server 2016 virtual machine in Azure here. And I'm working in a sample database. It's called the AdventureWorks 2016 database. It's a sample database that you can download to experiment with SQL Server. And what I'm going to do is I'm going to create a table. And you can see the syntax here. It's create table. And I've got this dbo.customer. Now, the dbo dot is the schema, or the namespace, if you like, where I want to create this table. So I'm giving it a fully qualified name, or at least a partially qualified name here, of the schema, and then the actual table name. So it's a table called customer that's in this thing called a schema called DBO. And the customer table is going to consist of a number of columns. We've got a customer ID column, which is going to store integer data. And it's a special kind of column. It's an identity column. So it's going to automatically increment a value with each new row that's added to the table. And it's the primary key for the table. It's the column that uniquely identifies each row in the table. So a customer ID will uniquely identify a customer row. We've then got a first name, and that's of type nvarchar. So in other words, it's going to support Unicode characters for my names, and I'm going to have a maximum length of 20 characters for someone's first name. And you'll see that that's specifically set to be not null. So I can't not put a value in this column. I can't leave that value null. I have to put in a first name. I've then got middle name, which again is an nvarchar of 20 characters, but this time I'm allowing nulls. So if someone doesn't have a middle name, then in theory we can just leave that null. And the same with last name. We've got an nvarchar 20, and again I'm allowing null. Some people don't have last names, they just have a first name. So we'll leave that null. It should be worth thinking about here that null could mean either this person doesn't have a middle name or last name, or it could just mean we don't know what the middle name or last name is. Null means unknown, effectively. We've got an account opened column here, which is a date. So we're recording the date that this customer opened their account. And in that one, we're assigning a default value of the current date. We're using this getDate function to calculate today's date. So if I don't specify, when I insert a value into here, if I don't specify when the account was opened, it will default to the value for the current date. And then I've got a credit limit that I'm going to assign to that. It's going to be a decimal value, and that's going to have 6 values in the number to 2 decimal places. So we've got this specified decimal size that we're going to store in there, and again we've got a default value of 1000. So we're going to allow a default credit limit of 1000. So that's the code to create the table. Let's go ahead and run that. I'll just select this particular statement, which is what I want to execute, and we'll go ahead and execute that. And off that goes. The command completed successfully, it tells me, so that's good news. And if I go and have a look in my database here, in my AdventureWorks 2016 database at tables, I should find in here, I might just have to refresh this view, that we have a DBO customer table. So there's that table, and I can see the columns that I've defined in that table. So it's gone off and it's created that table for me in my database. All right, so I'm now ready to do some work with that table. Let's scroll down and have a look at some more code here. And the first thing I might want to do is I might want to insert a row into that table. So I'm going to insert a new customer. So I'm inserting into the dbo.customer table these values. So I haven't specified any individual columns. I'm just saying insert into the table these values, and the values are in the order that the columns appear. Now you might notice I haven't specified a customer ID, because remember that was an identity column. So that's automatically going to be generated for me. But I am inserting the first name, the middle name, or the middle initial in this case, the last name, the account opened date, and the credit limit. So I'm explicitly entering the values for those columns other than the identity one, which is generated automatically for me. So we'll go ahead and select that. And off that goes. It says 1 row affected, so it's inserted that 1 row into the table now, which is good news for me. Well, let's look at some other ways of inserting data. In this case, we're going to insert some explicit nulls, and we're going to use some default values. So we're inserting into the DBO customer table again. And again, we're just inserting the values. But this time I'm saying that the first name is Rodrigo. There is no middle name, so I'm explicitly saying the middle name is null. Right? I'm explicitly saying there's nothing to be inserted in there. The last name is Romani. And then I want to insert the default value for the account open date and the default value for the credit limit. And remember, I specified what those defaults should be when I created the table. So I can go ahead and run that. And again, 1 row affected, it's inserted that row into the table. Well, the other thing I can do, because I've got columns that allow null values and I've got some default values specified for some of the columns, I don't have to insert something into every single column. I don't have to create these placeholder values to insert into the columns that accept nulls or defaults. I can just say I want to insert into DBO customer and then specify these are the columns that I'm inserting. I'm only inserting first name and last name. If there are any other columns, just use either a null if it supports nulls or a default if there's a default defined for that column. So let's insert Naomi Sharp into there. And again, that succeeds. One row affected. That's happily done that. And because I haven't specified things like the middle name or the account open date or the credit limit, it's used either a null or a default value for those. Now let's insert something that I know to be invalid. I'm going to insert a null first name and a middle initial and a last name and then a date and a credit limit. Now we specifically said that first names could not be null. So what happens if I try to insert a null into that location? Well, what happens is I get this error message at hearing. It says you cannot insert the value null into column first name. That statement has been terminated because we don't allow null first names. So here's a question for you, just to see if you've been paying attention here. We created the table and we specified that there is a default value for the credit limit. But I did not say whether or not it would also allow nulls. So if we have a look at our create table statement, here it is here. Here's my credit limit column. Credit limit is a decimal value with a default of 1,000, but I haven't said null or not null. I've left that ambiguous. And whether or not that's going to allow nulls depends on the settings that I have for the database. So until I actually run this, unless I explicitly know what the settings are for the database, I don't know whether this is going to succeed or fail. So if I run that, it actually succeeds. So the default in my database system is that columns will allow nulls. If I haven't specified null or not null, it will allow nulls. But I can change that behavior in the database. So you shouldn't rely on that. The point is that you should always be explicit when you're creating tables about whether you want to allow null values or not. Okay, so I've created my database. I've put all these rows, I've created my table rather. I've put all these rows into the table. I might want to actually get the data back out of the table. So let's go ahead and run this select statement. And it's going to select star from DBO customer. Star is the kind of shorthand for just bring me back everything that's in this table. Bring me back all of the columns is really what that means. So if I run that, sure enough, it brings back everything that's in there, and I can see those values. It's generated these identity values, 1, 2, 3, 5, because you remember there was one statement that I tried to insert that failed. So we tried to insert 4, that failed, and it just moves on to the next number, so we get to 5. And I've got my first names all in there. Where there's a null, I can see that it's highlighted. That's a null value in there. So it's not that the middle name is actually null. It's actually a null value that's in there. And I've got a null credit limit here in that last row that we inserted as well. Now I can bring back, rather than bring back all of the columns, it's kind of wasteful to do that. If you're doing this over a network and you've got a table with lots of columns, you probably don't want to bring them all back. You just bring back the columns that you're interested in. So I can specify that I only want the customer ID, the first name, and the last name from this table. So let's go ahead and run that. And sure enough, it brings back just the customer ID, first name, and last name. So I get that data. That's pretty good stuff. I can also do things like I can bring back calculated columns. So I've got a couple of different things going on here. I'm selecting the customer ID, and then I'm selecting the first name plus a space plus the last name as the full name. So the plus in this case, because these things are strings, these are nvarchar columns, it's going to treat this plus as a way of concatenating strings together. So it's going to be the first name and a space and the last name as the full name. Now the as really just gives a name to the column that gets returned. Because that's a calculation, it wouldn't actually have a column name when it gets brought back in the results down here. So we're giving it a name of full name. And then there's another calculation in here. I'm using a function called dateDiff, which measures in days. That's what the DD is. So dateDiff in days between the account opened and today's date. So in other words, how many days has the account been open for? And I'm going to call that account days. So don't worry too much about the details of the function. We're not really worried too much about that at this point. But what we're looking at here is we can have a select statement that involves not just specifying columns, but I can specify calculations on those columns and effectively derive new columns in the result that come back. So let's go and run that. And sure enough, it brings back my customer ID, the full name, which is the first name plus a space plus the last name, and the number of days that account has been opened. And of course, Rodrigo and Naomi here just used the default value for opening their account, which was today, so there haven't been any days between when it opened and today, so that's a 0. Now, what I've been doing so far is bringing back all of the rows. I'm bringing back specific columns, individual columns, but I'm bringing back all of the rows. I can actually filter the rows that come back as well as the columns. I can specify just bring me back the customer ID, first name, last name, and credit limit from the DBO customer table, where the credit limit is greater than 500. So bring me back only the rows where the customer has a credit limit of greater than 500. That's what that where clause does. That adds a filter. And if I do that, I can see that I've only got 2 customers who have a credit limit of greater than 500, and that's Rodrigo and Naomi, who have that default credit limit of 1,000. So that wraps up the demo for looking at creating tables. It's very simple. We've seen how to create a table, we've seen how to insert some rows into that table, and then how to use a select statement to bring back data out of the table. So hopefully that's useful.
All right, welcome back.
Yeah.
Let's talk about data types.
Yeah, indeed. So you saw that we created some tables there, and we created tables that had columns of particular data types. Those data types can be different, obviously, types of data. So one type of data might be character strings, so where you've got text effectively. So we could have fixed length character strings. A phone number is a good example where you might want to specify a fixed length. You could have variable length. We talked about variable length. So there's varchar and nvarchar types that we've seen. You've got large bodies of text, so maybe the equivalent of a document that you want to store. Technically, under the covers, it's stored slightly differently. It's not actually stored in the table. What you get in the table is a pointer to where that data is stored. But we can store large volumes of text. And we've got this idea of storing Unicode values. So where we've had varchar for variable length, we can have nvarchar for supporting character sets that aren't necessarily in the regular ASCII.
So anytime I've seen that N and an apostrophe in front of a data type or a string, that means it's that Unicode.
It's a Unicode value, yeah. And as well as strings, we can store numbers. So some of the numbers we've seen, you can store integers, whole numbers in other words, and there are different sizes of integer. You can specify a tiny int, a small int, a large int. Don't worry too much about the details of the specific size limits, but you can be efficient in your storage by specifying the maximum size of integer you want to store.
But you also want to plan ahead.
You do want to plan ahead.
You want to think about what the largest number you might need to store is.
Yeah. We can store exact decimals, precise decimals to a specific precision and scale. And we can also store approximate decimals, so floating point decimals, where you might get the odd rounding error depending on how you calculate that. So you've got this option for storing these different types of numbers. We can store temporal values. So if we need to deal with dates and times, actually that's a really common thing in databases. So you can store dates, you can store times, and you can store date and time. So we've got the things like an order date at the precise point during the day when that order was placed. And we can even store things like offsets. So if we know that we've got a meeting time for an international calendar application, perhaps that we're building, we can offset it from, in this case, perhaps UTC. So you're offsetting it from the time in the Greenwich Mean Time in London.
Now, about the birth date, that first birth date, 1971-03-07, is that March 7th or is that July 3rd?
So that is March 7th. I've specifically chosen a format that's a kind of recognized format because different countries do things differently. If you do it this way, you do the year, then the month, and the day, then two things happen. One is everybody can agree that that's the format. The other thing is that actually, if you were to sort that in alphabetical order, it's going to be in the right order because it's year, then month, and day.
Right.
And there are some other data types. There's more esoteric data types that you can store. So we've got things like bit for true-false values. We've got binary where you can store the binary that's perhaps encoding a photograph or a video or something like that. There's something called a unique identifier, a GUID. Sometimes you'll see it called a global unique identifier we can store. We can store XML. We've got a data type that supports XML. We'll talk a little bit about in one of the later modules. And similarly, we can store spatial data, so coordinates or shapes, geometrical shapes using spatial data. And then there's the idea of a timestamp. Timestamp's actually an integer value since sometime in the 70s. I can't remember exactly when it was, 1970 or something. But there's a specific date that's regularly used, quite often used in Unix systems as a timestamp. So the key points we've covered then, you're going to choose the most appropriate data type and size for your column, and you're going to have to think about the, as you say, the size eventually you might end up storing in there. So the biggest size you're going to need, and the appropriate data type, whether it's a string or a number or whatever. You are also going to have data types. Some of them can be implicitly converted. So for example, if I tell SQL Server to do an operation that multiplies an integer by a decimal number, that'll quite happily work. They're both numbers. And if I tell it to insert a string that's actually consisting of numbers into a numerical column, that will work, because SQL Server will say, well, you obviously meant that to be a number, right. I'll just convert it. But sometimes it won't be able to convert because it doesn't know what you mean. If you try and multiply a date by a string, that doesn't make any sense. So SQL Server will throw an error at that point.
And we can explicitly convert that using some built-in functions.
Exactly, right. Yeah. There's functions in SQL Server to do that. Well, why don't I go and show you some examples of working with data types so we can see some of this in action.
Sounds good. Let's see a demo.
Well, here we are back in SQL Server Management Studio. And previously we saw how to create a table, and we're going to create another table now. And I just want to pay a little bit more attention to the data types of the columns in this table. So we're creating a table called dbo.accountmanagers. The first column is the employee ID that identifies each of my account manager employees. And that's an integer, so it's a whole number that I'm creating there. Then I've got a first name, which is a varchar. A variable length character is what varchar means. And because it's var and not nvarchar, what we're saying is this supports the ASCII character set. So that kind of standard set of English language characters that can be stored in that. Then we've got a last name column which supports nvarchar. So again, it's a variable length character, it's a string, but this time because of the n at the beginning, we're supporting Unicode or wide characters. So that more extended character set that supports some characters that might exist in languages other than English. So perhaps kanji characters or something like that. We've got the date of birth, which is a date. Now, there are various different ways of storing temporal values. You can have dates and date time, which would store the date and the time. This is specifically just the date for the date of birth. And we've got a salary which has a decimal value in here. So we're storing a decimal value in here that has 10 digits supported altogether with 2 decimal places. So it's going to be accurate to 2 decimal places with 10 digits. So let's go ahead and run that create table statement. And that creates my table. And we'll insert some values into the account manager. So I'm inserting into here Lucas Sondergaard, and you can see that there are some characters in here. These are actually regular ASCII characters, so it wouldn't matter if it was varchar or nvarchar, but just to make the point, we can insert different characters into here. And I've got my date in here, and look, the date is actually in quotes. I'm treating it like a string, so I've got 1971-03-07, which is the 1971. The next thing is the month, so that's March 7th, 1971. And the salary that I'm putting in there is 92,000. So let's go ahead and insert that. And that all works as expected. We get our row inserted into the table. Well, let's have a look at Rosie Reeves. We're going to insert Rosie Reeves into here. And this time the date format's slightly different. I've got 12/12/1988. So it's in a different format, but SQL Server will still recognize that as a date. And I've got my value here, which is a decimal, but I've left off the decimal places here. So it's just a whole number that I've put. So I've actually entered an integer, is really what I've done there. But it can be treated as a decimal. We just assume that it's 0.00 that's going to go on the end of that. So I go ahead and do that, and that inserts that quite happily. Well, here's another one. This time I'm going to try and insert Deanna. And instead of a last name, I've actually put a number here. We're going to assume that Deanna has a last name that's actually a number, 8411. And we'll see what happens if we try and insert that. And actually, that succeeds. So we've got this number here. You might have been expecting that to fail and throw an error, but it doesn't, because all that happens is SQL Server says, well, you've missed out the quotes, but I'm just going to treat that as a string. So I'm going to take in that as a string of characters. I can't do any calculations with it because it's not actually going to store a number in the table. It's going to store the string 8411. It'll treat it as an nvarchar in this case. So here's another thing. I'm going to insert into my account managers Aisha Witt, and I've got a date there. And notice that I've got the number here, the salary, but I've prefixed it with a dollar symbol. So I've actually put the symbol for the currency that I'm putting in there, and we might expect that to fail because that's not technically a number. I've put a bit of a character in there. But actually, it's quite happy with that. SQL Server recognizes that as being a symbol that goes with numbers, so it just treats it as a decimal number. Now let's try and get a little more creative. I'm going to insert into here Elwood McGee with a date, and this time I've specified the salary as a string with the dollar symbol. So I've put it in quotes, so it treats it like a varchar value there, and I've put the dollar symbol in there. Now so far it's accepted numbers where we should be storing